Hello class. Today what we're going to look at is how to use congruent triangles. Okay, what can we do with them once we know that they're congruent? In the past couple of lessons we've seen how to prove triangles are congruent, right? And we had things like the side theorem, or the side angle side theorem, or the angle side angle, and all of those, hypotenuse leg, all of that, to prove that two triangles are congruent. So now the question is, okay, great, now that you know they're congruent, what are you going to do with it? Okay, and so that's what we're going to look at. And the important thing to know about congruent triangles is that if two triangles are congruent, every single piece of the one triangle is congruent to its corresponding part in the other triangle, right? And so what we have is that the corresponding parts of congruent triangles are congruent, which we just abbreviate as CPCTC. Corresponding parts of congruent triangles are congruent. So if you can prove the two triangles are congruent, then you know that all of the corresponding parts are congruent as well. Alright, so if we know that triangle ABC is congruent to triangle XYZ, then even without any markings on this, we know that segment AB is congruent to segment XY. We know that segment BC is congruent to segment YZ. We know that segment CA is congruent to segment ZX. And we know that angle A is congruent to angle X, angle B is congruent to angle Y, and angle C is congruent to angle Z. Okay? Because the corresponding parts of these two congruent triangles are congruent to each other. Alright? So then we can use them for other things. So let's take a look at some examples here. Alright? So in 1 through 3, we want to explain how to prove that the statement is true. We're not actually going to prove it, we just want to explain how to prove it. So let's take a look. In number 1, we want to prove that segment UV is congruent to segment XY. Alright. So UV is this segment here, XV. XV is this segment right there. Okay, we want to prove that they are congruent. They are in two different triangles, so if we know that the triangles are congruent, then we could show that those two sides are congruent, right? Well, triangle, they have marked one set of angles, they have marked one set of sides. We need a third thing, and apparently I already marked on this one. This angle here, these are vertical angles, so we know that these are also congruent, and so that means our two triangles are congruent. So I'm going to put that over here. We're going to say that triangle TUV is congruent to triangle, let's see, T goes with W, U goes with X, and V goes with V. By the, let's see, this would be angle side angle. Alright, so by ASA. And so if those two triangles are congruent, then we can conclude that segment UV is congruent to segment XV. Alright, UV is congruent to XV because these are in the corresponding positions. So segment UV is congruent to segment XV by CPCTC because the corresponding parts of these two congruent triangles are congruent to each other. Alright. Alright, let's take a look at number 2. Number 2, we have segment TS congruent to segment VR. Okay, so let's take a look at these two triangles. We have segment TS, segment VR. They are not marked congruent. So in order for us to say that they're congruent, we need to say that the triangles they are in are congruent. So how could I say that this triangle is congruent to that triangle? What do we have congruent? Well, let's see. We have right angles. Okay, so these are both right triangles, so maybe we can use our right triangle leg theorems. We have one side here that is a leg. This is the long leg on both of them, so they're corresponding legs. And the hypotenuse. So we have hypotenuse is congruent, we have legs congruent, so this is hypotenuse leg. So we can say that our triangle is congruent. Triangle TSR is congruent to triangle, let's see, TVU. No, S. S is the short side, so R. So VRU. And this is by hypotenuse leg. Okay. So now that I know the triangles are congruent, I can conclude that this side of the triangle is congruent to that side of the other triangle because they correspond to each other. So segment TS is congruent to segment VR by CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. Alright. So far, not too bad. Let's take a look at number 3. Alright, number 3. We need to prove that angle JLK, this one, is congruent to angle MLN. So we want to prove that these two angles are congruent. They are not vertical angles because this, we don't have a straight line here, right? So these are not vertical angles, so we can't do that. We're going to have to show that these two triangles are congruent like we did in the other ones. So let's see, what do we have? We have a set of sides, we have another set of sides, we have the angle that is in between these two congruent sides, and so this is side angle side. So triangle, let's see, JKL is congruent to triangle. Let's see, J goes with M, K goes with N, and L goes with L. All right. So triangle JKL is congruent to triangle MNL by, let's see, this was side angle side, so SAS. Okay. But we needed to show that the angles are congruent, not the sides. So the angles, we're looking at these two angles here. That's the angle L and the angle L in each triangle, and those do correspond with each other. So angle JLK is congruent to angle MLN by CPCTC, because corresponding parts of congruent triangles are congruent. All right. So not too bad. Not too bad. First, you show that the triangles are congruent, and then you know that each piece of the triangle is congruent to its corresponding part in the other triangle. So what we're going to do here, we're going to do some formal proofs. We're going to prove that angle 1 is congruent to angle 2. And I'm going to do this in a 2-column proof just because I like to do 2-column proofs. They're just easier for me. So let me set up my 2 columns. Statements over here and reasons over here. And if you don't like 2-column proofs, you want to do this as a paragraph proof, that's fine. You can do that. You can do it as a flowchart proof, whichever one you like. Okay, so we've got statements and reasons. We need to prove that angle 1 right here is congruent to angle 2 right there. Now, we do know some things already. We have these two angles congruent. We have these two segments congruent, and we have some right angles. Nothing about these angles specifically, though. So, what we need to do is somehow prove that the triangles that angle 1 and angle 2 are in are congruent to each other. And once we've done that, then we can show that angle 1 is congruent to angle 2. So let's see, what triangle is angle 1 in? Angle 1 is in this triangle here. Well, we've got that other line there. Possibly we could say it's in this triangle there. Okay. Angle 2 is over here in this triangle. Or maybe we could say that triangle. Okay, let's see. So let's start by writing out our givens while we kind of think about what we could do here. So statement 1 is all the given information, all the stuff that's already marked in the picture. So that would be segment GI is congruent to segment, JI is congruent to segment JG. Let's see, got these two angles there. So angle GIH is congruent to angle, what was it? There it is, IGF. And the other thing I was given is that angle FGH and angle, what was it, GHI are right angles. Are right angles. Okay, and all of this was given to me. Okay, so now while we're doing that, hopefully we're thinking about which triangles we could show are congruent to each other fairly simply. They contain angle 1 and angle 2. Alright, so now my first inclination is to say, let's use this right angle here. I could do something there. I have both of these right triangles have a side, so reflexive property. We've got an angle and a right angle, so I could do side, angle, angle. So angle, angle, side. Could do that. But angle 1 and angle 2, those aren't actually part of the right triangle, are they? It's stuck there in the middle. So maybe I can use these triangles here, like that. Okay, so these two triangles. And let's see, I've already got one angle congruent on those triangles. I've got a side congruent on those triangles, so I've got two things. And so what else could I do? I've got vertical angles there, so I can do that. So I really don't even need those right angles. They're just there to mess me up, which is very nice, but there we go. So we need to say that these angles here, so that'll be IJH, angle IJH is congruent to angle on this side here, FJG, FJG, because these are vertical angles, and so that is the vertical angle congruence theorem. Vertical angles congruence theorem. Congruence theorem. T-H-E-O-R-E. All right. Okay, so that gives me one angle, one side, and then another set of angles in both triangles, and so my triangles are congruent. So triangle, and I'm just looking at these little triangles here. Triangle IJH is congruent to triangle, let's see, I corresponds with G, and J corresponds with J, and H is going to correspond with F. By the, what was it, angle, side, angle, ASA. Alright, so now that I have that these two triangles are congruent, I know that each piece of the triangle is congruent to its corresponding part, and so that means that angle 1 is congruent to angle 2 because that is JHI congruent to JFG. They can corresponding parts. So there we go. Angle 4, step 4, these are congruent because of CPCTC. And there it is. Corresponding parts of congruent triangles are congruent. Alright? That one wasn't too bad. It was a little bit weird because they threw this right angle stuff in there to try to mess us up. But it didn't work. Alright, let's take a look at number 5. Alright, let's go ahead and set my two columns up here. I have statements. And I have reasons. Okay. Still trying to prove that angle 1 is congruent to angle 2 because that was the instruction for both of these. So let's see what we got. Don't have a whole lot given here. Let me go and write that down while I try and figure out what I'm doing. So I am given that segment AB is congruent to segment AD. And I am also given that segment BC is congruent to segment CD. That's it. These are both given. Alright, so angle 1 and angle 2 are sitting right there. Alright, so let's take a look at this. We need some triangles that we can prove congruent. Because if I can show that these two triangles are congruent, then I know that those pieces there are congruent. So The only thing I have, though, in these two triangles, I have this side here. Now I can get this one here, CE. I can show CE, and this triangle is congruent to CE and that triangle by the reflexive property. But that's still only two things, right? And I need three. Got to have three. So I've got two sides, and to make that work, I would need to have an angle. Now I would need to have this angle here, the angle in between the two sides, so I could have side angle side, because side angle doesn't work. I couldn't use one of those. So how could I get this angle congruent? Well, let's see, what else do we have? We have these two sides and those two sides. Well, that's a triangle there and a triangle there, right? So I could show those two triangles are congruent. Well, that's two. I need a third side. Well, AC would be my third side, and it's in both triangles, so that's reflexive property. So that would give me these two triangles are congruent. And if those two triangles are congruent, then all of the angles in those two triangles are congruent to its corresponding angle. So that would mean these two angles are congruent. And so then I could have my side angle side for this triangle there. So that's what we're going to do. So first, I'm going to say that segment AC is congruent to segment AC. Segment AC is congruent to segment AC because that is the reflexive property. Reflexive property. Alright. Next, that gives me 1, 2, 3 sides of one triangle congruent to 1, 2, 3 sides of the other one. So I can say triangle ABC is congruent to triangle, let's see, that would be ADC by side, side, side. Okay. Now, since those two triangles are congruent, that means these two angles are congruent because they correspond to each other. So angle, what is that? That would be ECB is congruent to angle ECD because those are corresponding parts of congruent triangles and they are congruent. So that gives me this angle. So now I need to say that this side here, segment EC. So 5, we have segment EC congruent to segment EC, because that's in both of these two triangles. Reflexive property. Reflexive property again. And so now I have one side, two sides, and the angle in between them. And that means these two triangles are congruent by SAS. So that would be step 6. Triangle ECB congruent to triangle ECD by side angle side, side angle side. And now that I have these two little triangles here congruent to each other, I can show that these two angles that are part of those little triangles are congruent to each other. So step 7, angle 1 is congruent to angle 2 because they are corresponding parts of congruent triangles, and so they are congruent to each other. So that one was a bit involved. Took a little bit more thought on that. But there we go. Corresponding parts of congruent triangles are congruent. That is very important to remember, and it is very useful. So that's what CPCTC says. If everything in this triangle is congruent to, if these two triangles are congruent, then every piece of this triangle is congruent to its corresponding part in the other triangle. And once you know they are congruent, then you can use them to do other things, like we did here. Once we knew that these two triangles were congruent, then I could use this piece to prove these two triangles were congruent. Alright? And so there it is. CPCTC, corresponding parts of congruent triangles are congruent. Oh, most important thing to remember, your triangles have to be congruent first. I can't say that AB is congruent to XY unless I already know that this triangle is congruent to that triangle. All right. So before you use CPCTC, you have to already know the triangles are congruent. That's the thing that most people mess up on that. So anyhow, I hope you found this useful, and I will see you next time.